Big O notation is generally used to calculate the running time of an algorithm. We know that some of the algorithms, they take much larger time as compared to other algorithms. Some algorithms we know that they take a much large time to compute the input we provide them, and they take a much larger time to give us the output. So basically the big O notation is the function that we assign to positive integers, and we generally call it Tn. So our target is basically to find out the worst running time of an algorithm. And we know that we have to find out the big O of function fn. To calculate the big O of function fn, we have to calculate the value of sufficiently large n. And we know that the Tn is above by the constant multiple of fn. So the main target of big O notation is to find the worst running time of an algorithm. Here we can see how we can calculate the big O notation of function fn. We assume that this line denotes the fn. Here is the Tn starting from here. But if we doubles the value of fn and make it 2fn, then it will cross the Tn value. So in this event, we would say that this Tn is indeed a big O of fn. The reason being that of sufficiently large n value. And once we go far enough outright on this graph, indeed a constant multiple times of fn, twice fn, is an upper bound of Tn value. So we can say in mathematics that eventually it should be bounded above by a constant multiple of fn. We see that there exist two constants. One is c and the other is n naught. And both c and naught should be greater than 0. Means they have a value of greater than 0. C obviously quantify the constant multiple of fn, and n naught is quantifying sufficiently large that the threshold beyond and c times is an upper bound on Tn. So c of course is just going here. We denote that this 2 is, the value of 2 is basically is c is equal to 2. This c value. And in this graph, n naught is basically, this n naught is the value where this 2fn will intersect the line of Tn. And here we can calculate the value of n naught. So here is the point. We can calculate that this is the value of n naught. And this is the value of c is equal to 2. So one way, think about it, if we are trying to establish that something is a big O of some function, it's like we are playing a game against an opponent and we want to prove that this inequality here holds, and our opponent must show that it doesn't hold for sufficiently large n. This one, we have to go first. Our job is to pick a strategy in the form of a constant c and a constant n naught. And our opponent is then allowed to pick any number n larger than n naught. So the function is big O of fn if we have a winning strategy in this game. If we can upfront commit to constant c and n naught, so that no matter how big is the n number our opponent picks, this inequality holds. If we have no winning strategy, then it's not big O of fn. So last thing in that these constant, the C and N naught, they do not depend on the value of N. However, the value of N is larger in any case. So C and N naught, they behave independent of the value of N.